discuss about eigenvalues and eigenvectors. In some books, eigenvalues are written as characteristic value or latent value. Eigenequations are written as characteristic equation and latent equation. And eigenvectors are written as characteristic vectors or latent vectors. Now, in some very normal language, let us understand this is an operator O. Suppose these are apples. And when this operator acts on this apple, let us say it gives us a magical machine, let us say. Then this is giving is 5 apples. This is what is this will become is this operator here in mathematics will become the matrix or any operator. These apples will take the shape of eigenvector. This will be your eigenvalue, this 5, and this again will be a eigenvector. Now let's come down to what exactly does this operator do is that you gives the same number, same operator number of times. That's the thing. Now let us see how to find this eigenvalue, how to find this lambda. This is lambda in Greek, L-A-M-M, lambda, L-A-M-M, L-A-M-M-D-A. Wait, let me write it clearly. Wait, sorry. Let me write it clearly. This is pronounced as lambda. This is the way it is. Now this is a Greek alphabet. Now let's forget all this introductory stuff. Let's come down to our thing. We will always consider, see, we will always consider a square matrix. Always consider square matrix. Square matrix. Square matrix. Always. Always. First point. Now the next thing is this. First, I will make you understand with a small example, and then we will go into more details. I'll do three examples on this. One in two cross two, and the other in 3x3. Because in GGSIPU syllabus, you have only 2x2 and 3x3. That's all. So what I'm going to do is that, see, I have a matrix A. Let me take one example: 0, 2, 2, 0. Now, how to write down the equation? How to write down this will be like a some vector x will give me lambda is equal to lambda x. Now a I know. Now bring this here in this on this side, a x minus lambda I. If I multiply with an identity matrix, it doesn't matter. With an x, I'll get 0. Take this x out. That means I mean to say a minus lambda I into x is 0. Remember, this identity matrix will be of the same order as that of A. If A is n cross n, then I will be also of n cross n. Both will be of same order. This is this needs to be kept in mind. Now let us see with this example that how to find this. See, how to find the eigenvalue. How to find eigenvalue. How to find eigenvalue. Wait, let me clearly write this. Wait. Eigenvalue. This is very important concept. How to find this? Now, what I will do is that I'll use this equation. A minus lambda I, I'll take a determinant and this should be equated to 0. Now, see how to use this. See very clearly. Now, make this one. Now, you have, I think 0, 2, 2, 0. And then you have minus lambda. I told you to write the same order. This is a 2 cross 2. So this also will be of 2 cross 2. And then you put this and this. 0 minus lambda. So this will become minus lambda. 2 minus 0. This will become 2. 2 minus 0 is again 2. And 0 minus lambda here will become minus lambda. Now the determinant should be equal to 0. Now you take the determinant. This is a 2 cross 2, very simple to take. You may just write here, cross multiply this. This is lambda square minus 4 equal to 0. And lambda square is equal to 4. So lambda is equal to plus minus under root, plus minus 2. If you take, that is, I'm talking about lambda is equal to under root of 4. Under root of 4. So you will get this. This is called, this equation is the characteristic equation. Characteristic equation. This equation is the characteristic equation and this this value, this lambda see, there are two values, lambda equal to plus or plus 2 and minus 2. So write lambda 1 is 2 and lambda 2 is also minus 2. So you can write it this way, you may write, or you may write like this, lambda 1 minus 2. It doesn't matter which one you want to take as plus 2 or minus 2, and lambda 2 is plus 2. This or this, whatever you call it, this are the eigenvalues, eigenvalues. Later on, I'll talk about the vectors. But still, I would like to talk about the vectors here only. Now you saw, you got two values, 2 and this. Let us see how to find the vectors. I have just told you this equation, a minus lambda I x equal to 0. Now see one thing. This is basically a homogeneous equation because this is like big, let us say, let b be equal to a minus lambda I. Then this looks like bx is 0 and is therefore this is a homogeneous equation. Homogeneous equation. Okay, now how will I find this vector x? How will I find this vector x? That's the point. Now my matrix was, see, my matrix was 0, 2, 2, 0. Now lambda, see, for, let me write like this, for lambda equal to 2, plus 2. I will write minus 2, 1, 0, 0, 1. And then I'll put a big bracket. Now, what order is this? 2 cross 2. So there will be only two vectors, x1, x2, and this will be equal to 0, 0. Let me draw the line here so that you don't get confused with that. Yes. Now see, I'll do the subtraction the way we did. We know how to subtract, we know how to add. Now this is going to become minus 2, this is going to become plus 2. But 0 minus 2 is minus 2, 2 minus 0 is 2, 2 minus 0 is 2, again 0 minus 2 is minus 2, and you will write x1, x2, and you will write 0, 0. This is the way you will write. Now, what you do is that take the row operation. R2 is R2 plus R1. Then what you get is minus 2, 2, 2 plus you are adding 2 minus 2 is 0, and minus 2 plus 2 is again 0. Now you have x1, x2, and this is equal to 0, 0. Now what you do is that, now you have minus 2x1, you multiply it in this way, the way you multiply matrices, 2x2 equal to 0. This can be written as minus x1 plus x2 equal to 0. Now any value of your thinking, you can think x1 as, you may think x1 as 1 and this as 1, then what will happen? This will behave like minus 1. If you take, I mean to say, take x1 equal to, take x1 equal to 1 and x2 also equal to 1. Take, say. So what will happen out of this equation? Minus 1 plus 1 will be 0. So this value is okay. Both can be 1, 1. You can take, but I'll tell you one thing. Take x1 as 2 and x2 as, say, minus x2 x2 as also 2. So minus 2 plus 2 will be 0. So basically you will take the smallest type of values. So my first vector x1 will be 1 and 1 vector. Now some people may ask that if I take if I take wait a minute, rather if I say if x1 is 0 and x2 is 0, then also the equation is getting satisfied. But x equal to 0, 0 is not a eigenvector. It is a zero vector. It is not an eigenvector. So I cannot take this. So I cannot take both zeros or all zeros. I hope you have understood this point, how to take the vectors in this case. Now let us see. This point you must keep in mind. This point, wait. This point, wait. This point wait a minute. Yes, this point you must keep in mind that you did not take all the components of the, these are the components of the vector, this one and this one. So this cannot be all be zeros. Now let us see for lambda equal to minus 2, what will happen? Again the same equation, a minus lambda I x equal to 0. Now we have 0 to 2 0 minus 2 and 1 0 0 1 whole bracket, again this x1 and x2, and then I get 0 0 0 0. Now see one thing in this. Now this will become 0 2 2 0, minus into minus will become plus 2 1 0 0 1, and then it will become x1 x2, and this will become 0 0. So what will you get from here? What will you get from here? You will get 0 plus 2 is 2, 2 plus 0 is 2, 2 plus 0 is 2, 0 plus 2 here will become 2, and then you will get x1, x2, and this will be 0, 0. So now again take the row operation, R2 is R2 minus R1. So what will you get? 2, 2, 2 minus 2 is 0, 2 minus 2 is 0. I hope you know how to do row operations. I need not tell every now and then. Now you have x1 and x2, and this is 0, 0. Now after this, what you will write is 2x1 plus 2x2 is equal to 0, implies x1 plus x2 is 0. That means what type of value should I take so that I get an equation? Again, I told you, do not take both the components x1 and x2 as 0. So x1 and x2 both cannot be 0. Not both. This is what I mean to say. So what are the options? You may take, wait, you may take this option. Say, I'm saying, say let that is, you take x1 as 1, you take x2 as minus 1, you take x1 as minus 1, you take x2 as 1, because the sum should satisfy this equation. That means plus 1 and minus 1 should be 0, minus 1 plus 1 should be 0. So the vector x2 can be either be 1 minus 1 or minus 1 1. It is immaterial. You may choose this, you may choose this. That's your choice. But preferably, there is no preference. You can choose. The most important thing is this. The most important thing is this. The eigenvectors corresponding to, these are the eigenvectors. This is x2. And then this is your x1. Wait, let me find your x1. Yes, this is your x1. Let me draw with a different color. Yes, let me put this in a different color, x1, and this is your x2. Let me draw this. Either this is your x2 or this is your x2. So see, eigenvectors corresponding to distinct eigenvalues distinct eigenvalues are, oh wait, let me write it clearly, are linearly independent. This is a very, very important point to note. They are not unique. You can say they are linearly independent. They are not unique. Now, sir, for example, I could have taken this vector or this. So they are not unique, but they are linearly independent. This x2 and this your x1, this x1 are linearly independent. This is a very, very important point to note. Now the next is I'll take a 3 cross 3 matrix, and then I'll show you how to find the characteristic equation and the eigenvalue. Let us take another question. Wait, sorry. This is question. The matrix is A. You may write B. That is your choice. I have a habit of writing A for all new matrices. 1, 2, minus 2, then 1, 1, 1, and then 1, 3, minus 1. Now do one thing is that as it is, AX is equal to lambda x. So A minus lambda I x is 0. Now what is A here? 1, 2, minus 2, 1, 1, 1, 1, 3, minus 1. Now lambda you need to find, put the lambda here. Now this is a 3 cross 3 matrix. So this has to be 3 cross identity matrix of third order, 0, 0, 1. Earlier it was 2 cross 2. So this was also 2, that was also 2 cross 2. Now this is 3 cross 3. So this also needs to be 3 cross 3. Now you have this, and then you have now you will have three vectors x2, x1, x2, x3. These are the components. This one, this one, this one are the components. Let me erase this. Okay, wait a minute. This is going to be 0, 0, 0. Now again, as usual, you will write down. See, this is the principal diagonal. Only whatever change will come is in the principal diagonal. Off diagonals, nothing will happen to these off diagonal elements. So see what is going to happen. 1 minus lambda, 2 minus 2, 1, 1 minus lambda, 1, 1, 3 minus 1 minus lambda, and this will be x1, x2, x3 equal to 0, 0, 0. Now, in order to find lambda, in order to find lambda, in order to find lambda, I need to have, in order to find lambda, A minus lambda I determinant should be 0. That means this whole determinant, the determinant of this thing should be 0. Determinant of this thing should be 0. Let me rub this. Okay, now let's copy that as it is. Copy that here in the determinant form. Wait a minute. Yes. 1 minus lambda, 2 minus 2, 1, 1 minus lambda, 1, 1, 3, take the minus out, 1 plus lambda, and then put this determinant and 0. Now you know how to do it. These are all like this. Now put a plus sign, put a minus sign, and put a plus sign on the top, and you expand it. And you expand it. So what will you get is, see, let me take some more. We need more area for this. Wait a minute. Wait a minute. Yes. Now see, 1 minus lambda, you are hiding this row and this column. So what you are left with? 1 minus lambda, 1, 3, minus 1 plus lambda. You are left with this. Now, now you need to hide. Now you need to hide the second column, this column. As you do in the determinant, same thing. So you put minus 2, you put minus 2, then you have, what you have is 1, 1, 1, minus 1 plus lambda. Wait, I took unnecessary too much of area. 1, 1, 1, 1 minus 1 plus lambda. This will come. Now the last row, last column needs to be hidden. This column is hidden. Plus into minus is minus. Minus 2. Now, oh, sorry, I need to write with the same color. Wait. Minus 2. Now you have 1, 1 minus lambda. Then you have 1 and 3. Now this determinant has to be 0. So let's do it. Let's do it now. Calculate it. See, 1 minus lambda, sorry. 1 minus lambda, 1 minus lambda. Then you have this bracket, you put a big bracket, square bracket, you put a square bracket. Now this is going to become minus a plus b and a minus b, a minus b and a plus b. This will become 1 minus lambda square minus 3, right? 1 minus lambda square minus 3 minus 2. This will become 1 minus lambda minus 1. The way you multiply this way. This will become minus 2. This will become 3 minus 1 plus lambda. I'm doing it directly. Now after you expand this, thing, look how it expands. Open it. 1 minus lambda, open up this minus 1 plus lambda square, minus 3, minus 2, then you have minus 2 minus lambda, then you have minus 2, then you have 2 plus lambda is equal to 0. Now, if you open up this equation, see, open up this equation, now you will have is 1, though this will become 1 minus lambda, then this will become minus 4 plus lambda square, then this is going to become plus 4, I'm multiplying actually inside, plus 4 plus 2 lambda, minus 4 and minus 2 lambda equal to 0. Now this is the situation. Now what you can do is that you are lucky enough that they have cancelled out. This cancels with this cancels with this. What are you left with is 1 minus lambda, and this is minus 4 plus lambda square equal to 0. So once this is 0, another time this is 0. So lambda, 1 minus lambda is 0, or minus 4 plus lambda square is 0. That is same as writing lambda minus 1 equal to 0, and or lambda square minus 4 equal to 0. This will give me lambda equal to 1, and this equation will give me lambda equal to under root of 4, that is lambda will be plus minus 2. So what are the eigenvalues? Lambda is equal to 1, 2 and minus 2. This is the way I found out the eigenvalues, and this was my characteristic equation. This was my characteristic equation. This was my characteristic equation, and these are my eigenvalues. One point to note that I like to tell you. What is the order of this matrix? What is the order? Wait a minute, let me write it clearly first. This is value. It is looking like R. Eigen. Let me write the whole thing clearly. Wait a minute. This is eigen values. Now, what is the order of this matrix? The matrix that I took. What is the order of this matrix? This is this matrix. I'm talking about this matrix. This matrix. What is the order? 3 cross 3. The matrix order is 3 cross 3. So I will get 3 eigenvalues. The earlier matrix was of order 2 cross 2. If you see, can you see this? This was of 2 cross 2 matrix. So I got 2 eigenvalues. Here it is 3 cross 3, therefore I got 3 eigenvalues. 4 cross 4 will give me 4 eigenvalues, and so on and so forth. So you must get 3 eigenvalues for a third order matrix, 4 eigenvalues for a fourth order matrix, 2 eigenvalues for a second order matrix. Now this was the normal this way of expanding. I mean to say, this big determinant finding and all that. I can tell you a shortcut method to do away with all this method, and they are very much valid method. For the shortcut method, it is lambda square minus trace of a lambda plus determinant. Just a minute. I think it just got erased. Plus determinant A equal to 0. This is the characteristic equation for a 2 cross 2 matrix to find lambda. Instead of finding the determinant in the above process that we did, this above process for the 2 cross 2 you have seen, we had taken the determinant of this. You have seen this way of doing things. Where is it? Here it is. Yes, I took the determinant here. You are seeing this determinant has been taken to find out these values of lambda. So instead of doing all this, you can straight away use this equation. To find the characteristic equation. This is basically the characteristic equation of a 2 cross 2 matrix. The whole of that. This whole of that is a characteristic equation of a 2 cross 2 matrix. You can use it to find lambda. Similarly, this is the characteristic equation of a 3 cross 3 matrix to find lambda. Now you only have in GGSIPU syllabus, you only have the 2 and the 3, 2 cross 2 and the 3 cross 3. These two are sufficient for you. Now you will be able to remember them with lot of practice. It will automatically come into you. I'm starting to do these questions using the first. I'll use this, then I'll use this to show that they give the same value. But before that, I'll tell you something about trace, something about determinant. What is the relation between trace and the eigenvalues? What is the relation between determinant and the eigenvalues? These are very, very important. Now see, first I'll take with the property of trace. First, property of trace. Trace, let me write down property of trace. This is very, very important for you all to know. Trace of A plus B is trace A plus trace B. Now, if it is a minus sign, then you will put a minus sign. Now, the second property is trace AB is equal to trace BA, provided they are all basically confirmable in this sense. I mean to say, basically this holds if A, B are confirmable. I've told you the meaning of confirmable while doing matrix multiplication. Confirmable. But here they will be, here they are all confirmable. Here all are confirmable. All are confirmable because all are because all these A comma B are all A B whatever matrix you take are n cross n type matrices. Type all n cross n cross n types. That's the point. Now the third is trace A B C. Now listen how to do this one. You draw a circle like this. Draw anti-clockwise. A, B, C. It is anti-clockwise. Anti-clockwise. It is anti-clockwise. So A, B, C. Now you will write, we start with B. That says B, C, A. And then you will write trace C, A, B. C, A, B. It is never possible that you write. Let me take some more page in this. Yes, it is never possible that suddenly you write it is trace B BAC or something of this. This is never possible. Now let me tell you what is the relation between trace and eigenvalues. Now see, now we will see these two very, 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 very important relation. Number one, trace of any matrix is equal to the sum of the eigenvalues. Sum of eigenvalues. All the eigenvalues. Rather I should say sum of all eigenvalues. All. Let's underline this word. All eigenvalues. Eigenvalues. That means if a matrix is of n cross n, and then it will have lambda 1 plus lambda 2 up to so on and so forth, lambda n. That is same as sum of the elements on the principal diagonal. I'll give you an example to understand this. I equal to 1 to n. Let's take, for example, let's take A is equal to A11, A12, A13, A21, A22, A23, and then you have A31, A32, and A33. So the principal diagonal elements are these. These are the principal diagonal elements. So now trace of this matrix A, I'm calling it A only, that is equal to, there will be three eigenvalues because it is of 3 cross 3, lambda 1 plus lambda 2 plus lambda 3, and this will be equal to A11 plus A22 plus A33. Do not make a mistake to think that, caution, I'll write down the caution. This is very, very important. This is a very, very important concept. And this is the actual concept, the total concept for n type. Though you have only of 2 cross 2 and 3 cross 3, Remember one thing here. Remember one thing here. Wait, just a minute. Let me make it more clear. Wait a minute. Wait a minute. Yes. Just a minute. This is trace. So here, do not confuse. Since I have written caution, caution, beware, don't write. I have written lambda 1 plus lambda 2 plus lambda 3 is equal to a11 plus a22 and a33. This does not mean, does not mean, this does not mean that lambda 1 is a11 or A22 or A33. It is not that. Neither lambda 2 is A11 or A22 or A33. Similarly for lambda 3, this is a caution for you all. So let me underline caution. This is a caution. Do not think this way. They are not equal to any one of these. I'll tell you with an example. Now similarly, the determinant of any matrix is the product of its eigenvalues lambda 1 into lambda 2 into lambda 3 into lambda 4 and so on and so forth into lambda n, where A is n cross n. Now similarly for the above matrix, this is the second most important point. Now I will try to explain you these 2 points with help of our example. The first example, just a minute. The first example is we had A equal to 0 to 0. I know the equation is lambda square minus trace A, trace A lambda plus determinant A. Now you already know trace A here is sum of these two elements, that is trace A is lambda 1 plus lambda 2 is basically 0 plus 0 is nothing but 0. And determinant A, you already know, you can find the determinant. This is lambda 1, lambda 2. That is, I think I should write one more word here, which I should have written. This is for trace. Yes, I should have written here. This whole thing, instead of writing this A cross n here, let me write this is valid for all all matrix of n cross n order. So I should have written product of eigenvalues, product of eigenvalues. For more reference, you can see a book of linear algebra by Chomsky. This is a, you can check there. You will find all this. Now, see one thing. Just a minute. Now, this lambda 1, lambda 2 is nothing but the determinant. And the determinant, sorry, it's not looking 0, it's looking like 6. Let's make it 0. Now, here the determinant is nothing but minus 4. Now, see one thing. So, using this formula, wait a minute, let me write, like, this is equal to 0. I may have left it out while writing. Now, this is the actual formula that I need to solve this problem. I need to write this in the examination. I need to write this in the examination. I need to write this in the examination. Now see, already if you look at this picture and if you have seen in your class 8th or ninth when you were doing equations, you have seen that suppose if there are two roots of an equation, lambda 1 and lambda 2, roots, I'm talking about roots now, in of class 8th or ninth, maybe somewhere like that, class 8th or ninth, maybe, then you used to write the equation as x square minus sum of roots, sum of roots into x minus plus minus plus product of roots. You may have done this in your class, smaller classes like 8th and 9th. The sum of the roots for this lambda 1 and lambda 2 is x square is nothing but minus lambda 1 plus lambda 2 x plus, and this determinant, the product was nothing of the but the determinant, that is lambda 1 lambda 2 equal to 0. Now compare this with this and compare this with this, you will get, wait a minute, yes, you will get this very equation. This, just a minute, this whole equation you will get. See, compare, you will get this only. Instead of x, I am using lambda square. Instead of lambda 1, lambda 2, I am writing lambda 1, lambda 2, I am writing trace A, and then instead of lambda 1 into lambda 2, instead of lambda 1, lambda 2, I'm writing determinant A. This equation you have already seen, but today you are seeing it in a different manner. Now I'm going to do this very problem that I took. Now let's put the values of 0 and 4 in this equation that we just saw. So lambda square minus 0 lambda plus minus 4 equal to 0. So now you have lambda square minus 4 equal to 0. Lambda is equal to under root of 4. That gives you lambda equal to 2 and minus 2. Now they are both distinct eigenvalues. So see, you may say lambda 1 is 2 and lambda 2 is minus 1. Or you may say lambda 1 is minus 2 or lambda 2 is 2. It depends upon you. It is a choice for you. Choice for you. What you want to say what? Choice for you. How you want to choose lambda 1. What value? Choice for you to assign values to lambda 1 and lambda 2 in this case. This was a 2 cross 2 matrix. Therefore, you got two roots. Now you see one more thing. Now let me take the 3 cross 3 equation. That means I will be helping you to using this one. Wait a minute. I will be helping you using this equation. Wait, this equation now I am going to help you use this equation. Now let's see how to use this one. Now see how to use this one, and we will do this by an example again. Let me click here. Yeah, I want some more page here. Yeah, now you let me take this example. I was taking a equal to, see, 1, 2, minus 2, then I had 1, 1, 1, then I had 1, 3, 1 minus lambda. Then what is the sum of the root? Trace of A. Trace of A was, let me draw the line here so the other problem is over there. Trace of A here will be lambda 1, lambda 2, lambda 3, and sorry, I made a mistake while writing. This ought to be minus 1. Yes. Lambda 1, lambda 2, lambda 3 is equal to 1 plus 1 minus 1, and this is plus 1. That does not mean that lambda 1 is 1 and lambda 2 is 1 and lambda 3 is 1. That does not mean, never do this mistake. Now let's find the determinant of A. Determinant of A is lambda 1, lambda 2, lambda 3. Very simple. Now you see what I do. Take this one plus, you put a plus sign, you put a minus sign, sorry, you put a minus sign and you put a plus sign. Now expand 1, then you hide this, you hide the first row and the first column, and you get minus 1, minus 3. Then you remove this column, you hide the second column, here you get minus 2. With minus 2 you get minus 1, minus 1, and now you hide the third column. When you hide the third column, you get minus 2, minus 2. Wait, sorry, I have to change the color. Minus 2, you get minus 2, and then you write 3 minus 1. So here you get is minus 4. You get is minus 4, or and then you get minus 2 plus 4, and then you get plus 2 here, and with minus 4, so this 2 cancels out, you get determinant as minus 4. So now you got trace and determinant. Now I will show you how to use A11. how to find A11? It will be exactly like you will be finding A minus C. M11 you found, no, minus A11. Now let me rub this all. Sorry. Let me rub this one, this. Let me rub all this. Now let's find A11. A11 is you have to hide the first row and the first column. You hide this. What do you get? Wait. What you get? A11. You write 1, 1, 3 minus 1. This is nothing but minus 1, minus 3, and this is nothing but minus 4. Let me draw a line for this one. So things are correct. Wait a minute. Now you have, this is 4. Now you have A22. What you do is that you hide the second row and the second column. Now see, this you remove, this you remove. Now you hide the second row and the second column. Whatever you see, you write it down. 1 minus 2, 1 minus 1. This is nothing but minus 1 minus 2 plus 2. And what you get is plus 1. Now let me drag a little bit down. Little bit. Let me drag it little bit. Wait. Yes. Now I will be able to find A33. That is nothing but like minor M33. You hide this row column. You remove this. Now you hide the third row. Wait. I took a wrong color. This. I hide this row and I hide this column. Now whatever I get, I write it down. I write 1, 2, 1 minus 1, 1. So I get 1 minus 2, that is minus 1. Now if I add them up all, A11, A22 and A33, I get 1, 1 is minus 4. This is plus A11, A22 is plus 1 and this is minus 1 and I get minus 4. But this value is important because this is my this value. This value. Now, this is a 4. Let me write it 4 properly. Wait. Sorry, wait. This is a 4. This is 4. Now I will put the value of this. I'll put the value of this and I'll use the value of this in the equation that I wrote earlier was this one. I hope you remember this equation. Wait. In this equation. Now see, I'm going to do one thing. I'm going to rewrite that equation down and then I'm going to solve this problem. Now let's write down for 3 cross 3. It's lambda cube minus trace A lambda square plus A11 plus A22 plus A33, and this is nothing but lambda minus determinant A equal to 0 lambda cube. I found trace as 1. So this is minus 1 into lambda square. A11 I found as this is 4. You can see trace A here. Just see the trace here. You can see trace A here. 1. This is the one. Let me write it little more clearly so that it really looks like 1. Wait. Yes. It is 1. Now the thing is, I'll put this value here. Minus 4 lambda and determinant I found out. Wait a minute. I found out the determinant. See, I found out the determinant here. Wait. I found out the determinant to be this. So now this is going to be minus of minus 4 equal to 0. So now what I will be doing, see, now my thing is like this. Now my equation, this is, now I'm going to rewrite it properly. Lambda cube minus lambda square minus 4 lambda plus 4 equal to 0. This is my characteristic character. This is going to be my characteristic equation or the latent equation, whatever you want to write. This is the most important equation. Now I need to solve it as I used to solve in class, small classes. I hope you remember. See, what I do is that I take the factor of 4. 1, 2, and 4. Let's try with the 1. See, if I try with 1, I'm doing rough here. Rough, I'm doing it. Don't do it in the fair copy. Do this in the rough, what I'm doing now. What I'm doing now is the rough. Now see, I put 1 minus 4 plus 4, I get 0. Therefore, lambda equal to 1 is the root. I used to write this in class 8, root. Now I will not write the word root. I will write the word eigenvalue. I will write eigenvalue. This is V. V, I don't know why it becomes R, I don't know. It's a V. Wait a minute. It's a V. Eigenvalue. Now, what you do is that, see, this equation you need to keep in mind. This equation you need to keep in mind. Now you see what happens. Now lambda minus 1 is a factor. So lambda minus 1 divides, this you did in class 8, 9. Lambda cube minus lambda square minus 4 lambda plus 4. Now you do take is lambda square. You get lambda cube minus lambda square. Take a minus sign and plus sign. They cancel out. Now you take a 4 lambda plus 4. You take a 4 lambda. Now you take minus 4. And now you get is minus 4 lambda plus 4. And they cancel out each other. And you get a 0. So what are this was the rough work. This was the rough, I'm telling you. Wait, yes. This was all the rough work that I did. All the rough work that I did to find out the factors for this equation. To find the factors for this equation, this is the rough work I did. But let me close down the rough work. Yes. And then now what I'll do is that, what I will do is this. I will drag it down and I'll write lambda cube minus lambda square minus 4 lambda plus 4 equal to 0 is nothing but lambda minus 1, and lambda square minus 4 equal to 0. This will give me lambda equal to 1, or it will give me lambda square equal to 4. So from here I'll get lambda equal to 1, 2 and minus 2. This is the way I'm getting my your eigenvalues for a 3 cross 3 matrix. Now you see, this method was a little shorter than this method of finding all this. You can see determinant and all this stuff here. Here I'm talking in order to find lambda, you have to do all this. So I'll tell you one more shortcut method, but that is, I'll be using this, but I'll be using some trick. I will be using some trick. Now you see what trick I use. I have the same equation. For the first, I have the same equation. See, I have the same equation for the first. Hey, 1 minute. 1 minute. 1 minute. Hey, 1 minute. I don't know why the pen is not. Yes, now it's working. Now the thing is this. I had your A equal to. I'm doing with one example so that you can do the later on example. Now you see lambda 1 plus lambda 2 is 0 and lambda 1, lambda 2 is 4. Lambda 1 and lambda 2 came out to be minus 4. Now see one thing, and my equation came out to be lambda square minus 4 equal to 0. See, you need to write this. You need to write this characteristic equation. This characteristic. Now, what I will do is do something in the rough. This is what I am doing in the rough. Now see one thing. This is a 2 cross 2. That means there will be only two roots. Two roots. What are the factors of 4? Write down the factor. Either it is 4 or 1, or it is 2, 2. That's all. So if I use 4 and 1 and I add them, I will never get 0. Are you getting my point? If I take one root 4, the other root 1, and I add them, what I do is this, I add 4 and 5, I'll get 5. That is never equal to 0. So this option is neglected. Now I take one more thing. I take 2 and 2. I take 2 and 2. Now if I add this 2 and 2, what do I get? I get equal to 4. Again, there is a 0 here, which is not equal to 0. This option is neglected. Now see, I'm doing all things in rough. Now I take minus 4 and 1. So see one thing, the sum minus 4 plus 1 is minus 3, which is not equal to 0. So this option is also neglected. Now see, if I take 2 and minus 2, 2 and minus 2, 2 minus 2 and 2. See, if I add them up, I am getting a 0, which is equal to 0 in this equation. Now, if I add the multiply minus 2 into 2, I'll get minus 4, which is same as here. So, therefore, the two roots are this. So, see, what I will be doing is, I'll do all these things in rough, and this will be in fair. And I have this characteristic equation, I'll come down straight with 2 and minus 2. Instead of showing all that calculation, I can do this trick also. Now come to the third one, the second one, second example. I had, wait, I had this question. Wait, I had this question. I gave you this thing. See, I gave you this thing. The question was A is equal to. What I'm trying to show you is that I'm trying to show you learn some tricks so that the time consumption in the examination hall is very, very less. So these tricks, if you know, if these tricks are up your sleeves, you can just play them and save your time. Now you know this expression lambda cube minus trace A. You need to write down this. There is no alternative. And all this A11 plus A22 and A33, and you have A33 lambda minus determinant A is equal to 0. You need to find all this and put it. So what you get is you got was minus lambda square plus minus 4 lambda plus 4. Now see one thing, you got trace A as, this was trace A. This is lambda 1, lambda 2 and lambda 3 as plus 1. I hope you got this point. You had already found it earlier. And determinant A is basically lambda 1, lambda 2, lambda 3 and equal to, I think it was minus 4. Now see the fun I'll do. Till here, I have to do what I have to do. Instead of doing all this, listen, instead of, wait. Instead of doing this type of rough work, I'm talking about this division and all this cumbersome division. I can do one thing. I can just use a trick. What trick I will use? See, very simple. This is what a 3 cross 3 matrix. Undoubtedly, I'll have three eigenvalues. Now, what is the determinant? Minus 4. So do one thing in the rough. In the rough, what you do? Let me now I can cover this matrix. Yes, I need only two information: trace and determinant. Now in the rough, what I'll do is that in the rough I'll do see some business I'll do. In the rough, what I'll do is that listen. In this rough, I'll take the factors of 4. See, minus 4 and 1. I cannot take because this is, there are two values and I need three values. So this is not possible. These are two values and I need three eigenvalues. Now I'll take 2, 2 and 1. There are three, but if I multiply them, I will never get minus 4. I will never get minus 4. I will never get minus 4. If I multiply them, I will get 2 into 2 into 2 into 1 and I will 4, which is never minus 4. So this option is gone. Now, what I do is that if I take 2, 2 and minus 1, of course I'll get minus 4. 2, 2 and minus 1, I'll get minus 4 undoubtedly. But the problem will be with the trace now. If I take the trace, 2 plus 2 plus minus 1, I'll get 3, which is not equal to, that is not equal to, I think it is 1. I hope so. Trace is 1. Yeah, it is not equal to 1. So the last alternative is 2 plus 2 and 1. Now you do one thing. Is that you add this 2 plus 1, you will get 1. You multiply all of them, you will get minus 4. And that's why lambdas are eigenvalues are 1, 2 and minus 2. Another matrix, let us say A with this 0, 1, 1, minus 1 and 0. Now we try to find out the eigenvalues of this matrix. See, the trace of A here is 0 plus 0 is 0. That is equal to lambda 1 plus lambda 2. And the determinant of A is lambda 1, lambda 2. And this is nothing but plus 1. Now, in rough, you will do some, you know the formula, lambda square minus trace A into lambda plus determinant A is equal to 0. So lambda square minus 0 lambda plus 1 equal to 0. This will give me lambda square plus 1 equal to 0. So lambda square is going to become minus 1. Lambda is going to become under root of minus 1. That means lambda is equal to iota and minus iota. I have already discussed about complex numbers in the video of Hermitian matrix. See that this is iota and minus iota. Let's check this. Multiply these two. Multiply these two. Iota into minus iota. This will give me minus iota square, and minus 1 will give me plus 1, and this is what I get. Now I add this iota plus and minus iota, I get 0, and which is this. So these are the two eigenvalues. This is one. This is the complex eigenvalues I have got. Now let's take another question on this. Let's take another question on this now. Yes. Let me take this question. Let me draw the line. Yes. Now, see one more question. We have a equal to 1, 2, 3, 1, 2, minus 3. Wait. 1, 2, minus 3, and then we have 0, 3, 2, and then 0, 0, minus 2. Now trace A comes out to be lambda 1 plus lambda 2 plus lambda 3, and this is equal to 4 minus 2 is 2, and determinant A is equal to lambda 1, lambda 2, lambda 3. Very simple it is. Just hide this row and this column, and you will get is minus 2 into 3 minus 0, and this is nothing but minus 6. Now A11, let me remove these lines. Wait a minute. This was 2. Now let me hide this and hide this. This is A11. This is A11. And then this is 3, 2, 0, minus 2. So you will get minus 6. A22. You will have to remove this this line and this line. And now you will have to hide this and this. So now you will get is 1 minus 3, 0 minus 2. So you will get minus 2. Now you will get A33. A33 is, you will have to remove this. Now hide this and hide this. And of course, you have already found this was the determinant. 1, 2, sorry. This is 1, 2, 0, 3. And so you will get a 3 here. Now the formula is lambda cube minus trace A lambda square plus A11 plus A22 plus A33 lambda minus determinant A is equal to 0. This will give me the characteristic equation. lambda cube minus trace is 2 lambda square plus minus 6 plus 3, that is minus 3 and minus 5. I'll get minus 5 lambda, and determinant is minus 6, and here is a minus, so plus 6 equal to 0. So what I'll do is that I'll get lambda cube minus 2 lambda square minus 5 lambda plus 6. Now I'll show you a shortcut trick instead of using that class 8 method of doing it the earlier way I showed it. See, you got minus 6. See, I'll do it in the rough. See, I got the sum as lambda 1, lambda 2, lambda 3 as minus 2. And the product I got is minus 6. So take the factor of 6. 3, 2, 1. So what you do is that you take minus 3, you have to, you take it is as, you take 3 as positive, 4 and 2. I think I got this is plus 2. Sorry, this I got as plus 2. Sorry. This, let me see the trace. Let me check the trace. Let me check the trace. Trace is plus 2. Sorry. The trace is plus 2. The trace is plus 2. The trace is plus 2. Now see, I need the sum to be 2, and that's so what I do is that I put a minus sign on this, see, on this 2. So what I get, if I multiply 3 into minus 2 into 1, I'll get minus 6. Now if I add, then 3 minus 2 plus 1, that is 1 plus 1 and 2. So my eigenvalues are, instead of doing that algebraic method, you can do this in the rough. And then I'll get the eigenvalues as 1, 3 and minus 2. This is a shortcut method of finding. What I've done is that I have found out this product already, and the trace I already found out. Now what I have done is that I have taken the factors of 6. See, what are the factors of 6? 6, 1, 1, 3, 2, 1. Now basically I have to take this one because I have to get 3 eigenvalues. Otherwise 3, 2 is 6 would have done the job. But I want 3, 2 into 1. Now I will adjust this in such a manner that the product will give me minus 6 and the sum will give me plus 2. That I have done here and I have done here. I have done here and I have done here. Therefore, the eigenvalues are this. Now, you see one more thing that if I take one more example for you, things will be more easier to understand this shortcut method. How to after this characteristic equation, how can you directly get this answer without doing this type of division? Wait, I'll show you the division that I did earlier. This division, for this rough work. I need not. I can avoid this completely. I can avoid this completely by this trick that I used here. Just a minute here. I use this trick here. No, I use this trick here. This trick can be used to find out the eigenvalues directly. I'll take one more problem to make you understand. Now see, let me draw the line. Yes. Now see, I'll take another problem. Let me take a equal to 1, 2, 3 and 2 minus 1, 4 and then 3, 1 minus 1. Now write trace A. Trace A is 1, lambda 1 plus lambda 2 plus lambda 3, and this is equal to 1 minus 1 minus 1, and this will give me minus 1. Now let's take the determinant of A. Take the determinant of A. Now see, this is lambda 1, lambda 2, lambda 3, and you have plus sign, a minus sign, and a plus sign. Now you expand this way, this way. So what you will get is, you will get 1 time plus 1 minus 4. Right? I'm doing it directly now. Now this is to be done directly. Look, wait, yes. Now I will hide this. Sorry. This color is not to be used. this color. This is hidden. Now I will hide this one. Now you see, you will get minus 2, and then this is going to be minus 2 minus 12. Minus 2, you will get minus 2, 2, and you will get minus 12. That's right. Minus 2 and minus 12. That's right. Now you will, wait, there was a 1 here. Now you will hide this one. Now you will have plus 3, sorry, plus 3, you will have plus 3, and then you have 2 plus 3. Now you see what you get. Solve it. This is minus 3, minus 2 into minus 14, plus 3 into 5. So you get is minus 3 plus 28 plus 15. That is equal to 25 plus 15. 25 plus 5 is 30, and this is 40. You get 40 is the determinant. 40 is the determinant. Now let us find A11. Let me hide this. Let me hide this. Now, yes. Now let me even erase those plus minus signs. Wait. This sign has to be erased. This whole, this whole. Now do one thing. Now let's find A11. A11 in short. We will find it in very short. A11, I'm doing a direct multiplication. See, I will be hiding this and this. So minus 1 and minus 4. Plus 1 and minus 4. Minus 1 into minus 1 into minus 1, and this will become minus 4. Plus 1 minus 4 is minus 3. So I'll get minus 3. A22. A22 is this way. Wait. This way. Let me rub this colors. Now I will hide this one. Sorry. Extremely sorry. 2 minus 1. This is. Wait. Now I will hide this. And I'll hide this. And directly I will get. See. Minus 1 and minus 9. That is minus 10. I'll get minus 10. Now when I get minus 10. Now I'll go for A33. I'll go for A33. In that case, I'll just remove this. Now I will hide, just a minute. Now I'll hide this and this, and I'll get minus 1 minus 4, that is minus 5. I'll get minus 5. So now I've got everything. This I'm rubbing, this I'm rubbing. Now I'll write down the equation directly. See, lambda cube, wait a minute, lambda cube. Now minus trace is minus 1 though, so it is plus 1 plus lambda square. Sum this up. Minus 3 minus 5 minus 8 minus 10 minus 18 minus 18 lambda, and minus the determinant 40. I'm using this formula. Yeah? Lambda's cube minus, I'm using this formula. I'm using this formula. Trace A lambda square, this is cube, plus your A11, A22, A33 lambda minus determinant A is 0. I'm using this formula. So now what I'll do is that instead of splitting this equation and dividing like in smaller classes, what I'll do, use a different technique. I'll use it in the rough. See, lambda 1 plus lambda 2 plus lambda 3 came out to be minus 1. Came out to be minus 1, and the product came out to be 40. Now you take the factors of 40. See, yeah, it could be 40 into 1, but then this won't give me minus 1, and but this will give me plus this. So this is not possible. Now let's take the other one. Break it into 3 factors. At least I need 3 factors, because I need 3 roots, because this is a lambda. See, this is a lambda cube equation. I cannot have 2 factors. I need 3 factors. So this won't work. This will not work. So what I'll do is that 5 8s are 40 and into, and say let's take 1. Now I want, see, 5 into 8 into 1 will give me 40. There is no doubt about it. But then there is a problem. This won't give me minus 1. 5 minus 8 is minus 3 and plus 1. If I give, I'll get minus 2. So this won't give me the factor. Now I'll try to check other ways. See, so I'll try to break this. 2 into 2 into for 4. 4 5s are 20. So let me make it. Again, there is a 2. Now there are 4 factors. I need only 3. So what I have to do is that 4, 5 and 2. Let me see. So I want minus 1 and I want a plus 40. So what I do is that I put a minus sign on 4. I put a minus sign on 2. See what happens. Minus 4 and minus 2. If you add, see, I'm dragging it a little down. You'll understand what I'm up to. Minus 4 minus 2 plus 5 will give me minus 6 plus 5, and this will give me minus 1, what I wanted here. Now you multiply minus 4 minus into 5 into minus 2. This minus and minus will become plus. 5 4s are 20, 22 is 40. So my factors are minus 4, 5 and minus 2.